Look up on a clear winter night and you can find this star yourself. It looks calm, ordinary, safe. It is none of those things. It is a dying monster the size of a solar system, and the version you see might already be gone. Its name is Betelgeuse. And for as long as humans have looked up, the sky has been lying to us about it. You already know where it is, the constellation Orion, the hunter. 3 bright stars in a row for his belt. Now find his shoulder, the bright one, burning faintly red. That red star is Betelgeuse. Our sun is big enough to hold 1,000,000 Earths inside it. Hold that thought. Betelgeuse is big enough to hold 1,000,000,000 suns, not Earths, suns. Drop it where our sun is, and it would swallow Mercury, then Venus, then Earth, then Mars. Its surface would reach out into the asteroid belt, clawing toward Jupiter. Everything you have ever stood on would be deep inside this single star, vaporized, gone. It is not just big, it is bloated, swollen, a star that has lost control of itself. And it is young, only about 8 million years old. Our sun is a calm 4.5 billion. It glows red for a strange reason. Its huge surface is actually cool, about half the heat of our sun. But Betelgeuse lived fast. The biggest stars always do. And the bill is coming due. A star this size does not grow old gently. It burns through itself, and then it dies screaming. To see how close that is, you have to look inside it, into the core, where the clock is ticking. Every star is a war. Gravity crushing inward, fusion pushing back out. Burn fuel and you win. Push back against the crush. Run out of fuel and you lose. Our sun burns hydrogen. It has done so for billions of years. It will for billions more. Betelgeuse burned through its hydrogen long ago, so it moved to the next fuel, then the next, helium, then carbon, then neon, oxygen, silicon, each one harder to burn than the last. And here is the terrifying part. Each fuel buys less time than the one before. Hydrogen lasted millions of years, helium around 1 million more, carbon a few centuries, neon about a year, oxygen a few months, and silicon, the last real fuel of all, about a single day. 1 day. A star 8 million years old, down to its final hours of fuel. When the silicon is gone, the core fills with iron, and iron is the end of the road. Iron does not give energy back when you burn it. Iron takes energy away. So the fire that held the star up for 8 million years simply stops. And gravity, which has been waiting this whole time, finally wins. The core collapses in less than a second, faster than you could blink. We know all this. So in 2019, when Betelgeuse started to fade, the world held its breath. It dimmed, not a little. It dropped to a fraction of its normal brightness in just a few months. Astronomers called it the Great Dimming. Telescopes everywhere locked onto one red star. Everyone was thinking the same forbidden thought. Is this it? Is it about to blow? People watched the sky and waited for it to tear open. For weeks. It didn't. The dimming had a different cause, and in a way, a stranger one. Betelgeuse had belched out a vast cloud of its own dust, a veil drifting across its face. For a few months, the giant had partly hidden itself behind its own breath. It wasn't the death, but it was a warning. This star is restless, convulsing, close. And then, watching that closely, astronomers noticed something else, something nobody expected. Betelgeuse brightens and dims on 2 clocks. a short one, and a long one, about 6 years. That slow 6-year pulse had no good explanation until they did the math. The best answer? Betelgeuse is not alone. Something is orbiting it, a small companion star circling the giant, buried in its glare, hidden for all of history. In 2024, astronomer Meredith Joyce predicted it. In 2025, a NASA team caught it with a camera in Hawaii called Alopike, a faint little star tucked right up against the monster. Astronomers nicknamed it Betelbuddy, but there is nothing friendly about its future. Its orbit is slowly decaying. Inch by inch, century by century, it is spiraling inward toward the giant's outer layers. In maybe 10,000 years, Betelgeuse will reach out and swallow its only companion whole. But the companion is not what kills Betelgeuse. Nothing outside it can. The end comes from within. Return to that collapsing core. Less than a second, the whole star falling inward at once. The inner core slams to a halt, impossibly dense, and the rest of the star bounces off it. A shockwave tears outward. The outer layers are blasted into space at a fraction of light speed. For a few days, this single dying star will outshine its entire galaxy of billions of stars. That is a supernova, and Betelgeuse is the closest star to us that is ready to become one. So what would we see here on Earth when it finally goes? First, nothing. The light needs centuries to cross the gap. We only see it when it arrives. But we might get a whisper of warning. The collapsing core fires off a flood of ghostly particles. They are called neutrinos. They barely touch matter, so they escape first and reach us hours early. Detectors buried deep underground, a network called SNOOZE, would catch them. For a few hours, we'd know, before the sky did. And then, without warning, a new light appears in Orion, and it grows and grows. Within days, it would blaze as bright as the half moon, squeezed into a single point, bright enough to see in broad daylight, bright enough to cast soft shadows at night. For months, the brightest star humans have ever witnessed would hang in our sky. Every person alive would look up at the same thing. The whole species, watching one death. And here is the part that should comfort you and chill you at the same time. It cannot hurt us. At this distance, the blast is pure spectacle. Earth feels nothing. We would not be in danger. We would simply be in the audience, the best seats in history. Then, slowly, over months, it fades. Over years, it disappears. And Orion loses his shoulder. A star humans steered ships by, just gone. What's left behind is not nothing. It is something stranger. The crushed core survives, squeezed into a city-sized ball heavier than the sun. A neutron star. Or, just possibly, a black hole where the giant used to be. A teaspoon of that core would weigh as much as a mountain, the monster's corpse. But now, come back to tonight, to the red star on Orion's shoulder, and remember the lie. Betelgeuse is about 550 light-years away, so its light takes centuries to reach us. The light landing in your eye tonight left that star around the year 1500. You are not seeing Betelgeuse as it is. You are seeing a ghost of what it was. The real Betelgeuse, right now, is 5 centuries further into its death than the one you see. It almost certainly still burns, but it might not. It could have already exploded. And if it has, the light of that death is already crossing the dark toward us, racing across 500 years of empty space. and we would have no way to know. So go outside tonight, find Orion, find the red star on his shoulder, and know that you might be looking at a star that is already gone and is only waiting to tell us.